If you're ever in the future using this, say, I don't know, months in the future, and we're going through this bootcamp, and you're using 0.31 or 0.32, and something doesn't work, definitely make sure that you use the right dependency. Also, as a general note, if you ever run into issues, you can always double check the project link in our GitHub repository. It will be in the description below, and you can go that and check all the code and make sure that you're all set up correctly. All right, so we have the right Anchor version. We have our librs. The first thing I'm going to do, just to make sure that I did everything correctly, is I'm going to go cd into Anchor, and I'm going to do an Anchor build. This is how you build your smart contract locally. And let's make this slightly bigger for people to be able to view it. And so this Anchor build will compile our smart contract, and I'm going to do it early just to make sure I didn't screw everything up. I often will say build early and often. You'll hear this throughout the whole bootcamp on whoever's teaching, so that you don't have to run into issues later on and be missing a bunch of errors. You would rather run into the error as soon as it pops up rather than working backwards in your code. All right, so this built everything. You can see that it gave me a warning. This is because I'm not using this yet. We'll use it later, but that's okay. We'll work through it. So going back to our diagram, we can see that we had three instructions actually: initialize poll, initialize candidate, and vote. So we can just actually build those out right now. So in order to build those out, we can see that, so I actually have Copilot installed. I will also be using Copilot throughout this. Highly recommend using it. It's really useful. You can already see that it's trying to get me to create an initialized voting instruction. I'm going to ignore it and just do it myself, but it's a cool thing to go through. So we know that the public function, and we had this as initialize poll. We have to initialize the poll first. And we grab the context. So this is context. We're going to call it initialize poll. We're going to give it a poll ID. We're going to make this like a U64, so you can just have a bunch of polls. And then we're going to return, right now we're going to return OK. All right, so that's a base instruction. I'm going to create underscores here. So these underscores are basically just to denote I'm not using the variables, just to remove the warnings. We're going to anchor build, make sure we do everything right. So we can see that something went wrong. Let us make sure that we do it all correct. Oh, it's because the initialize poll we haven't done yet. So let's get started with that. All right, so one of the things that it noticed actually before we get started is that the program result's not correct. It's actually result, and that is correct. So now if we do a clear, so let's do a clear real quick and then rebuild, it should just have the context error. So there you go. So you have the context of initialize poll is not found. Perfect. So let's go build it. So if you remember in the previous example or previous project we built, we used the account macro or the derive accounts macro. So derive accounts. And we're going to create this as a struct called initialize poll. You can see it's, Copilot kind of already knows what we're doing. Doesn't know entirely, but we're going to create it ourselves. So struct initialize poll. We're going to use a lifetime for this, and then we have to create a bunch of different accounts within this context. As part of this initialize poll, we're going to be creating accounts. So that means we need two accounts already. We need the signer, and we need the system program. Now, Anchor is really nice. It'll actually pull in the system program already to you, so you don't have to worry about that. We'll just need the signer. So let's go build that signer. So it would be, because we're getting money from it, it's a mutable signer. And then we just have this as a pub. I'm going to call it signer because it's just nice. Signer info. So we know this is getting created. Perfect. Great. We have a signer that's going to be used to pay for this account. So next thing that we need to do, if you remember correctly, we had the poll account. So we need to create an account for the poll. So let's go ahead and create it. So account, and I'll fill everything in just a moment. We just want to make sure that we set it up. So poll, this will be account info poll. That works out. And down here, we're going to create that struct real quick. So I'm going to use account. We're going to do pub struct poll. And we're going to put everything in this. So we're going to have a pub poll ID. So it already kind of knows what we're doing. Thank you, Copilot. So we're going to have a poll ID. That's going to be U64 as we mentioned earlier. We have a description. So this is pub description. We're going to call this a string. We have a poll start. So pub poll start. That's also going to be U64 because that's how you measure. It's going to be a Unix timestamp. We have poll end, which is also going to be U64. And then we have a poll index. We can have this, or we had it as a candidate amount. So candidate amount. And we're going to have this as U64. So this is everything in our poll. This should be everything that we need right here. And so we should be able to create it right here, create the account right here. So let's go build it out. If you remember last time, and Copilot is giving us all the answers ahead of time, is that you can use init to make a account automatically initialize. The next thing is we're going to have the pair. We have to denote which pair it is, so we're going to have to give it the pair. We have to give it the space involved. And so we had some variable stuff here. We have a string. We have a bunch of U64s. U64s, we know how many bytes they are, but the string might be a different amount of bytes. So we have to use something called max length to give, it's in a macro, to give the max length that this string could possibly be. So let's go ahead and give that right here. All right, so to do that, we're actually using a macro called max_len, and we can just give the number of characters that this string can possibly be. So I'm going to just put 32, and that should be good. I think that's good enough. We could give, I guess we can do like a Twitter post, 280 characters. We can put a whole bunch of description in there. That should be good enough for this. So we have the pair, we have the size, and we're going to do another thing. There's another thing called init space that allows you to automatically calculate the space, and you don't have to do some extra work or math in your head to figure out how much space this is called. So in order to do that, you do hash, it's going to be derive init space. And so this basically allows you to get the space very easily. So when we do the space here, you can do space, whoops. It'll be always 8 because the way that Anchor does in the current version is that it always has 8 bytes reserved to it. So 8 plus poll init space. I think it's actually init space. There we go. And then we need the seeds. So if you remember earlier, we have the seeds as the poll ID. So we can actually pull that in and use that as a seed. So we're going to do seeds. You can see it as poll as ref. It's not exactly what we're going to do, but that's okay. We'll update it. All right, so the way that you pull in different parameters that you use is you'll actually use a macro called instruction. And you can see it pulls in the poll ID as a U64. And then what you can do is you can then use the poll ID. I think it's as ref. To do a seed for this poll account. So this seeds sets up the poll ID as seeds to get that poll account. And then finally, as explained earlier, you always need the bump. So we always have the bump in the poll. We have the signer, we have the poll. And I believe we can just run this now. Let's go ahead and do Anchor build. Build early and often. Let's see if we run into errors. We did run into errors. Let's go fix them real quick. So traits bump, blah, 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 poll. Okay, so let's see. Oh, let's keep going up. Not found in scope. So it looks like something is not set as the same thing. Let's see, I did use that correctly. Undeclared, usualize. We always have to go to like the top error. Good thing about the Rust analyzer, sorry, the Rust compiler, is it actually gives really good errors. So it says here, the program, okay, cool. initialized poll is not found in the scope. So something is wrong with this initialized poll. And that's fine. We can get there. All right, so we can see here, just looking at the error, the top error is use program type to add a system program field to your validation struct. This is because I'm creating an account. I actually need the system program. So pub system program. It's going to be a program of info system. So let's go rebuild it. Should have one other error, and that is fine. Okay, so now we have another error. We can see that other error disappeared. We can see that, oh, I understand. I did pair. We actually called it the signer. So it's just, that's okay. There's some misspellings. We do anchor build, and it looks like it's building. So that wasn't that hard. Just as a heads up, if you ever do run into errors, definitely go to the Solana Stack Exchange, and if you can't figure it out, and ask a question about the errors. It is very important when you do ask a question, however, to provide all the code necessary for someone to reproduce your error. If you don't give all the code, they might not be able to have enough information to give you an answer how to fix your code. So right here we have anchor build, and voila, we have initialized poll. However, if you know it right immediately, you can see we don't do anything with the poll. We have the context, we have the poll ID, but we just return OK. Now, note with Anchor, and this took me a while to figure out my first time, is that if you have this init, it does create the account. So that is OK. However, there's nothing in that. So we need to give some information to it. So some of the other stuff that we have is we have a poll start and end. So we actually have to have that passed in as part of the parameters. So let's go ahead and add those real quick. And I'm going to take out the underscores because we're going to start using it, using all of these different things. So next thing is we have a poll start. This is going to be the U64 we're going to pass in. And then we have a poll end. That's also going to be a U64. And then finally, we have this description that we talked about. And we're going to, for this last variable, this candidate amount, we're going to use that to increment later. We don't have to do that in the initialization, but we do need to make sure that it's set to 0. So let's go ahead and set it. So we're going to do let poll equals mutable context.accounts.poll. This is so that we can update the poll account. And we're going to set everything. So poll ID equals the ID we passed in. The description is the description we passed in. We will make sure the poll start is set. And the poll end is set. And then the candidate amount we're going to set as 0. So this is everything to initialize that poll. So we have our first instruction. We're all good to go. So an important part of local development is testing your smart contract. What we're going to do is each individual instruction that we build out on this voting application, we're going to test using a testing framework called Anchor Bank Run. So let's go pull that up. All right, so if you just look it up, it's called Anchor Bank Run. And you'll see that it is a testing framework that allows you to test your smart contracts methods or your instructions and make sure that you're expecting the right values to come out. So let's go test it out. So the first thing that you need to do is you'll have to do this yarn add anchor bank run thing. I'm using npm, so I'm just going to do npm install. Use whatever your flavor package manager for Node is to install it. So it is called anchor bank run. All right, so we've installed it, and now we have to get started. So if you go over here, there is a counter spec.ts. You go click on that, and there's already a test in there for the counter program. We're not using a counter program anymore, so we're just going to remove all of the information within it and create a new test. So let's go remove the whole thing and remove some more of the code. And I'm going to call this, or let's remove the counter because it doesn't exist. I'm going to call this voting, and we're going to call this initialize voting, or initialize poll, because we're initializing the poll with our instruction that we just built. So going back to the actual code, there's a few things that you need to do ahead of time in order to make sure these tests run. So one of the things is you'll have to go grab the program, the smart contract binary, and paste it into a folder called fixtures so that it knows what smart contract to use. We're going to do this manually now. However, later we'll do some things to make a trick to where it automatically copies over whenever you do build. So right here, in target deploy, you'll see a voting.so file. We're just going to copy it, and we're going to paste it into a fixture. So create a new folder called fixtures and paste it there. The next thing that I'm going to have to do is I'm going to have to pull what's called an IDL, which is kind of like an interface to help build and generate language-specific format for calling smart contracts. It's, if you're familiar with like Ethereum or something, it's similar to the ABI in those ecosystems. So I'm going to go grab that. We can see here, this is the voting IDL. It is under target IDL. It's called voting.json. We can see here in the example here that it is const IDL equals require the Puppet JSON, which is Puppet is the smart contract that they're using in this example. All right, so let's go copy it over. So we're going to do const IDL equals require, just like the other one, except for we're going to grab voting.json. So it grabbed it immediately. The other thing that we're going to have to do is we're going to have to grab the program type. So our program type is under the types folder, which is under target. So let's go grab that. So we'll just import it. Import, it'll be called voting in our case, from target types voting. And so we have the IDL and voting. Now we can create what's called the context and provider that allows us to interact with our smart contract. So let's just copy these, and we can get to using them in just a moment. So I'm going to put them right here. You can see it's erroring out. That's okay. It's because it doesn't have start anchor. We can just import it real quick. Let's say import. We can grab it over here and import at the top. Perfect. So it knows what it's talking about. Our tests are local to our folder instead of this tests, which are in a specific test folder. So we just leave this as nothing because it's just going to test what's there. And then there's, if you look here, there is extra programs, which is added programs and accounts. We're going to not do anything for the added accounts, but we'll do something for the extra programs. We're going to need the program ID, so I'm going to create a public key right here. This is going to be voting smart contract address, or voting address, let's call it that. And we're going to call it, it's a new public key. And we're going to copy the same public key that we have within our code. So if you go over to your lib.rs, you can copy over the ELY. For my case, it'll probably look different for your voting contract. So now we have the address, and we can put that in our thing. And if you look at start anchor, added programs, it has a name and a program ID. So we have to go add this right here. So we're going to do name. I'm going to just call it voting. And the program ID is just going to be our voting address. There we go. So we have the context, we have the provider. Now we have to create the program object. So you can see here that the program object is just created using the program type. So our type is called voting with the IDL and the provider. So this one's going to be called voting program. All right, so we have everything to get started. And Anchor makes it very easy to interact with different smart contracts using the IDL. Because with this voting program, and you can already see Copilot telling us what to do, is we can actually just do await voting program dot methods dot initialize poll, and then give our parameters. All right, so we have initialize poll, and that's our method. And if you look at our previous our actual instruction, it has poll ID, description, poll start, and poll end. So let's fill that out. So in order to do a U64 in TypeScript, you have to do new, and you can see it already knows what to do, anchor.bn, and we're going to have the ID of 1. The next type that we need is we need the description. So we're going to create this, what is your favorite type of peanut butter? The next two U64s that we're needing is the poll start and poll end. So these are actually Unix timestamps. So let's just go pull a Unix timestamp real quick. UnixTimestamp.com, copy the timestamp, and we're going to do another new anchor BN, big number. I'm going to do this at the beginning of existence at 0, and then we're going to do another one we'll just add a bunch of time at the end. So let me go didn't grab this, so let's just grab that real quick. There we go. So I'm going to add a bunch of time at the end. This is just increasing numbers significantly. This will be much in the future. So if I were to like copy this and paste this to convert to see what time it would be, this is in 2027. So it's years ahead of our current time, and we're good to go. So now we do the initialize poll. The last thing you need to do is you actually have to call the RPC with it. So this .rpc after the methods call actually will call the RPC to execute the instruction within the program. All right, so we've done that. Let us test it and see if it all works. So anchor test. All right, so it tested. It ran, looks like it ran, found test screen. Error configure port is already in use. So one thing that we need to do is with anchor tests, we're already running both a validator, a Solana test validator behind the scenes. So we actually needed to skip it. So skip local test validator, I believe, or maybe it's local validator. It's always good to read the manual beforehand to see if what you're doing is correct. So you can see it's skip local validator. And then we also need to do skip deploy because we're using anchor bank run, which allows us to skip a bunch of steps and run directly within the validator, or what's called the bank part of the validator, instead of running on a very heavy lift of the local test validator. So let's all run that. So anchor test skip local validator and skip deploy. And so this will run our test. You can see here it's found our test script. It's loaded our program. The one thing that we'll see right here is that it's going to fail because it doesn't know what this voting program is. And the reason being is you can see here that it says counter. And that's not running one of the recognizable program names. So let's go update that. If you go over to anchor toml, you're going to see that in here we have programs.localnet counter equals that address. So we need to update that. So let's go update that to our current program, which we called voting. Then we run the tests, and if everything is done correctly, it will pass successfully. So we can see here, it tested our voting program from our binary file, and everything looks like it worked correctly. It did the initialize poll check. Now, note, this is not a good test. It doesn't do anything. It doesn't check anything. So we actually need to go pull that account and make sure that we did everything correct. So one thing we're going to have to do is we're going to have to go grab that poll address. So this is going to be the poll address from our program-derived address, because if you remember, our seeds for the poll account is the poll ID. So we have to do this dot public key dot find program address sync, and we have to give the seeds. So the seeds will be it'll be buffer. Actually, it'll be new anchor dot bn of 1. So that is the actual .2 array-like buffer, little endian, 8 bytes. This is how you grab the buffer from a U64. So we have that, and then finally we have to give the program address. So this requires the seeds and the program address. So that will be the voting address. Perfect. So this should be a poll address. that is going to be created based off of this initialize poll instruction. And let's go verify it. We're going to first console log it. We're going to grab the poll account and then console log it. So const poll equals await voting program account poll fetch poll address. So this is saying, hey, fetch the poll account off of this address. And now we're going to console log it. All right, let's go see what it looks like. All right, so we can see it passed. And we can see right here, we have our poll ID of 1. We have the description there. Poll start is at the beginning of time. Poll end is this number. And then candidate amount, there's no candidates yet, so we have 0 candidates. So we've tested it, all looks great, it's fantastic. Now we can do some expects so that this test is actually a good test, because currently it doesn't actually test anything. So let's do some of those tests. So right now, we can do 2 of them, because we have the poll. We can go grab it, and you can see it says poll ID toNumber equal 1, and then we can do another poll. It's not the question, whoops. It's going to be the description equals this, what is your favorite type of peanut butter? And then we can also do, just for good measure, we can expect that poll description, poll start to be less than, so let's go grab that. Should be less than poll end, because we know that it should always be under that amount. So let's go, also we have to change these to numbers, otherwise it won't work correctly. Poll start to number. All right, so let's test it. Make sure that our test actually passes. All right, so our test passed. You can see the poll got logged, and the poll account was actually initialized. So we've done everything to initialize the poll. Now we can get to initializing candidates, which will be very similar to what we just did to initialize the poll. So let's go back to the program and start building that out. All right, so the next instruction, if you remember from this diagram over here, is we have the initialize candidate. So let's go build it out. It's going to be initialize candidate. We have to create a new context using different accounts. Context initialize candidate is the context name. We're going to have the candidate name. And do we need anything else for a candidate name? We don't need candidate votes because they're going to be set at 0. We also need the poll ID, otherwise we can't pull the right poll that this is related to. It's going to return. We're going to just have a OK return first. So let's just return OK. All right, so we have that. Now we need to go create the actual account struct. So let's once again, we're going to do derive accounts. We're going to use, if you remember, one of the seeds is the candidate name, and the other seed is actually poll ID. So we need both the instruction information. So this is going to be instruction candidate name poll ID. One thing to note, at the current time, you need to make sure that they're in the same order, because it'll actually pull the parameters after the context in the same order that they are listed in the actual instruction. So if you don't have them in the same order, you'll actually get the wrong data. So just a quick note, this will be pub struct initialize candidate. All right, so there's a few things that we'll need. So as we saw last time, we absolutely need the system program because we're going to be creating a candidate account. Same thing, we're going to need a signer because someone has got to pay for that new candidate account. We're going to need the poll because we have to use it to increment the amount of candidates that are within the poll. And then finally, we need the candidate count, which we'll do in just a moment. So one thing you might have noticed is that in our poll count, we originally had pairs, signer, space. Because we don't actually need to create it, we're just referencing it, we'll just do seeds equals the seeds and the bump. Finally, let's go create our other account. So this will be a new account. This will be a candidate. You can see it already started pulling everything. We'll have the poll ID and the candidate name, so it's just a separation or switch of these two, and those are our two seeds. Then we have the bump. So then we go to pub candidate account info candidate, and now we have to go create that actual candidate account. So once again, account pub struct candidate, and it's going to have candidate name and candidate votes. All right, so we have the candidate. We have all the information for the candidate account. One thing that you note, we used init space again, so we're going to have to derive init space yet again, like we did on poll on candidate. And let's do an anchor build, just to make sure. We've done a lot of code. Build early and often. You can see I made a error here. It's because I used string, so we must use a max length. We can do that again and grab this on the candidate name. So I'm going to say the candidate name, the names are normally not longer than 32 characters, so let's lower that to 32 characters. Probably lower it even more to like 16 after a little bit of testing, but that's okay. You can see that we got a bunch of warnings. These are just because we didn't use these different parameters yet, but it did build successfully, which is a good thing. That's why you always build early and often, otherwise you have to go redo a bunch of code. All right, so we have a candidate name, we have the poll ID. Poll ID is actually never going to be used, so we make sure that it is underscore. The candidate name will be used, but it's not. It's going to be used like this, so we can actually make that underscore as well to get rid of that error. It's going to be used in the instruction down below. The final thing is we have the candidate. So some of the things that we're going to have here, actually the candidate name will be used. All right, there we go. So we're going to set the candidate name in the account. So let candidate equal the mutable context accounts candidate. So we grab the candidate account, candidate name equals candidate name, and then candidate votes equals 0, because you need to always start with 0. Let's go build that, make sure it works all right. All right, cool. So it pulled this. We have the initialized candidate. All right, so now it's time to test initializing the candidate. So what we're going to do is we're going to create a new test right up here. It's going to be integration test initialize candidate. And we're going to test making sure that we're actually initializing our crunchy and smooth peanut butter and everything works as expected. So we have this. I'm going to also create, just for the future reference, because we're going to have to vote, I'm going to create a vote test because we know it's going to happen, so might as well have it there. So we have a vote test. And now, because we have multiple tests, I want to make sure that I pull this context provider and voting program out so I never have to use them again. So we're going to quickly set them over here. So this is context, let provider, and let voting program. And we're going to do a before all. And we're going to create a function that runs and sets these so that we always have them before every integration test. And we just pull these guys right back up there. Oops. There we go. Copy and paste. Remove the const. This is an async. And we got to remove these consts as well because they're always going to use the provider and the voting program from above. Actually, we don't even need them at all, so we just remove them. Perfect. All right, so let's run it, make sure that it still runs. So we don't want to have to have done all that and it breaks. That wouldn't be great. All right, so we have all our three tests passing. The initialize poll, as expected, is doing what it needs to do. Initialize candidate and vote don't do anything yet, so I hope those passed. It did. So now let's build the initialize candidate one. So it should be very simple. We should just be able to call the initialize candidate instruction. So if you remember the vote program or the initialize candidate program, it took a candidate name and then a poll ID. So we have to go put those both in there as parameters. So this one's going to be, we're going to switch it to be smooth first and then the number. Make sure you set the name first, or set the same parameter order that you had in your instruction. Otherwise, you will get an error. And so this is our ID of our poll for smooth. I'm going to do this twice for both crunchy and smooth. I'm going to see if it runs. Let's make sure it runs correctly. All right, cool. So I was able to create the crunchy and smooth candidates. And I believe if we run it again, okay, so it's doing the initialized candidate. Perfect. Okay, so we've initialized those two candidates, but that doesn't really mean anything unless you actually grab the candidates. So let's go grab them real quick. So const, we need to go get the crunchy address. It's going to use find program address sync. And if you looked at our actual, our seeds, our poll ID and candidate name, so one of the seeds is already there. The first seed is poll ID. Let's just verify with our lib.rs, our actual smart contract. The first seed is the poll ID, then there's candidate name. So let's set that up correctly. So poll ID should be first, which is new anchor, let's just comma, anchor.bn, and it's what we had earlier. So if we can just pull the same code that we had earlier to array like buffer, LE, or the little endian 8, and crunchy. So that's the crunchy address. And then we can just for before we move forward, let's go grab that candidate. Crunchy candidate equals await, get the candidate count, and let's go console log it. All right, so let's test it. All right, so you can see here the candidate name is crunchy, candidate votes is 0. Let's grab the other candidate. So I'm just going to copy and paste this code and change everything to use smooth. And then once we have all that set up, it should be ready to go. There we go. So I've copy and pasted it. Now we have all smooth. And we should be able to see the console log for both smooth and crunchy. There they are. They both have 0 votes. Perfect. So we have all those things. Now let's actually do some real tests. So you have to, I'm going to set them all because we just initialized them. The most important thing is that the votes should equal 0. So if you look over here, the candidate account, let's go grab him real quick. His candidate votes should be 0. So it's going to be candidate votes equal to, I guess it's 2 number, is equal to 0. New BN, new anchor, because we have to make sure it's equal to the U64 big number format. Let's make sure that works as expected. Perfect. Okay. So expected 00 got 0. So it's equal to the same. We just have the wrong format. So let's update that. Candidate votes equal. I think it's because it's already a beak number, so we have to make sure it equals the same. There we go. Let's see what it got. 0, 0, received 2. Interesting. Let's see what we did wrong here. So received, expected, received was 2. Okay. So it's probably because we did the, let's see, candidate votes, big number. So I think we can just do 0 here, actually. Let's check. There we go. Because we send it to number. There we go. So we set it to number, and it's equal to a number versus the big number equivalent. So this expect, we can copy and paste it right over here. And we can use it for the same smooth candidate. And so now we have 2 tests to make sure that their votes are 0, because that's the most important part, that whenever you initialize, they initialize as 0. Because if they initialize as more than 0, then it's basically cheating the system. You're getting more votes for your candidate than you previously had. So next thing, we're going to create a vote instruction. So let's go create that right here. So it's going to be pub function vote. See, it already knows what to vote. We're going to have, it says candidate ID. It's not actually a candidate ID. We're going to be voting for a specific candidate name. And there's our string. It's going to output a result. One of the things that we actually didn't do in initialize candidate, now that I just remember, is that the poll, if you remember correctly, the poll had a candidate amount. So we actually have to also increment the poll. So let's go do that real quick. Equals reference poll, and then do poll plus equals 1. All right, so that's set up. Our vote amount is we have to grab the candidate from the candidate accounts, because we're going to set up this vote context in just a moment. We'll call it candidate, so it's all the same, and just plus equals 1. So let's go create that vote context. So once again, drive accounts. There is nothing, is there anything? Okay, so we still need the candidate name. It needs the poll address, because you have to vote for a poll address. So let's grab that as well. It's going to be the same thing as over here, actually. There we go. So candidate name, poll ID. So it's going to be the exact same thing. We're going to have to pull a lot of the same accounts, except for you're not going to have to create any accounts. So we can remove the system program, because we're not creating accounts. You can remove all of these initialize things. So you just have the seeds and bump. Do we need that? We need the signer, because there's still a signer on the address, but it's not mutable, because it's not paying for an account. And then we need the pub struct. So we called this the vote context. So we need to make sure that we set that correctly. So pub struct vote, and let us anchor build it. Let's make sure I didn't mess up anything. It looks like I did run into an error, so let's just double check. Oh, it's because I don't have the lifetime set up on the struct correctly. So that got rid of some things. And then, let's see, the public account could not resolve. That's specifically the signer, because I'm not doing anything special with that. Remove that, and it should all work. There we go. One thing that it said is that it didn't know what to do with candidate name. I think it's because it's in here and doesn't actually use anything. We're just passing it in so that we can derive the account successfully. So now, since we added the underscore, it should compile with no error or no warnings. There we go. It works. So what we need to do, once again, you copy and paste. So copy that voting.sol over here. Voting.so over here into fixtures. And then we should be able to write the spec, the test for it. So let's go vote for one of our candidates. So what we can do is we can do an await voting program dot methods dot vote, and we have to vote for our specific candidate, and we have to always remember to hit the RPC. All right, so what we need to do is make sure that we're always going to pass the same thing, so candidate name, then poll ID. So the first candidate name will be our same ones that we did earlier. So right here, I'm going to vote for smooth, because that's the kind of peanut butter I like. It's going to have a poll ID of 1, and that is fine. And then we have the RPC calls it, and let's see if that worked. Let's see if this part just worked, because that'll tell us whether or not the RPC worked. So let's do anchor test. Remember always to skip local validator because we're using bank run, and then skip deploy because once again we're using bank run. So we get to skip a bunch of steps and see if it worked. So it worked. However, we don't know what actually happened. We can see that the vote actually was working here. So we know that it's actually voting, which is great. We know that the vote instruction is being called. We don't know actually what it's doing, though. So let's go grab that vote account and verify exactly what is happening there. So we'll have to go and get the address. So const, we'll have to go get the smooth address. So it's actually, we can copy and paste this up above and then just pull it from there and expect it equal to 1. So let's go grab it. So smooth address, it is the same address as before, voting address. We have the smooth candidate, and we need to make sure the equals to 1 now because we have voted for smooth at exactly 1 time. So it ran into an error. Let's see what it expected. Expected received 0. Okay, so let's figure out what happened here to where it did not increment 1. Did we actually plus 1? Candidate votes to number. Smooth candidate, so this is fetching the smooth address. It should have incremented because we did a vote RPC. That should have worked. Let's see, expected 1, received 0. So something happened to where it did not increment. So let's figure out what happened. So we have the candidate votes, we did a plus equals to 1, and we sent an OK. So why did this not increment? Let's figure out. So one thing that you can always do is you can actually send messages or logs to figure out how many votes something has in your smart contract. So we're going to anchor build this, and I'm going to pull this over and verify that this logic is working as expected. If it works as expected, that's great. We're good to go. And we just need to figure out what else might have happened. So let's go copy over the .so again. We copy and paste. And let us test it. And we should be able to get logs, the program logs, that it tells us exactly what happened. So we go up here. We can see the votes for 1. So something was being pulled that did not happen as expected. So it got voted for 1. That's great. It came back. It was 1 vote. We did get it afterwards. I wonder if let's go pull the actual account address. So smooth candidate, fetch account address. It should have happened after the vote. It's perfect. All right, so this is actually a really good point to make. It did not increment earlier because even though the library was saying I incremented whenever we did this message. And this is because all accounts by default are immutable on Solana. So unless you say that the account is mutable, it will not actually update the account even if you pull in the candidate account as mutable. It doesn't matter because by default this candidate account will also always be immutable. So we actually have to go here and we have to make sure we declare the account as mutable. And we didn't do this earlier, so actually the poll account also didn't update. So I'll add those 2 things. So now that we added mutable, so let's do an anchor build. All right, and then we got to copy over our .so file again. Copy it over to our fixtures. And then let us run the test. Perfect. So all 3 passed. We can see that the candidate vote for smooth is 1. We can see it's not the errors, but the logs went from 0 to 1 here, as expected. And from here, what we have is we have a fully working voting smart contract. We have tests that test it. And that's all we're going to do for this project. We have all the stuff on the smart contract side. Everything's interacting. We've run tests on local. We've run everything locally on the local test validator. We have our full local environment set up for success. In the next project, we'll actually be using this vote smart contract and putting kind of a front end on it, but making it more social. So look out to the next project. And for that, I will see you next time. For this next project, we're going to bring the previous voting application to people's favorite websites using Solana Actions and Blinks. Solana Actions are a specification for an API that can return a transaction on Solana to be previewed, signed, and sent. Whether it is a button, website, or QR code, Actions make it simple for developers to integrate the things you can do throughout the Solana ecosystem right into your environment. Blinks are blockchain links. They turn any action into a shareable link, allowing any website that supports links to be the starting point of a Solana transaction. As a result, Blinks transform websites or social media into a platform for executing transactions, all without taking the user elsewhere. Any website could be the surface for your new application, creating both a decentralized and user-friendly experience. In practice, Actions resemble a typical REST API call. A user interacting with a website would trigger a GET call to retrieve information about what actions are available. Following the list of available actions, the user can then choose an action to execute, which will then start the transaction signing process. We will be making all our votes in our previous application be actions, allowing them to be executed without a traditional front end with the help of Blinks. Now that we've had an overview of Blinks and Actions, let's get started building them. All right, so with the project that we just completed, the voting application, we're going to add something called Blinks and Actions. There is a lot of different amount of work that you'd have to do for Blinks and Actions. We're going to go pull up the docs right here, just kind of go through all the ins and outs of the technical know-how. So first off, we can see this says Actions and Blinks as the title here. We can see that to get started, we need to do npm install @solana/actions. So let's go ahead and do that right here. So we're going to have to go outside of our anchor folder. Let's start with the voting dapp and install our @solana actions. And with what we're going to do, we're actually going to need to add a couple steps that we didn't do in the previous project to make sure that the Blinks and Actions work for this project. So one of those steps is we never deployed our Anchor smart contract to our local test validator. We were just using a Solana bank run to do all the testing. But now we actually have to test on a local test validator to bootstrap some UI on top of it. So let's go into the Anchor folder, and we're going to do Anchor deploy. Now, this might be different based off your Solana config. So actually, you might need to check that first. So if you do Solana config get, you'll get a bunch of data based off of what environment you are set up with. If you want to set your config environment to local, you would just do Solana config set-ul. That will set everything to local so that you can just do Anchor deploy. So let's do Anchor deploy. And what this will do is it will actually deploy that voting binary that we used yesterday to our local test validator. And we can see here the program ID is that. And let's go check it out in the Explorer real quick. So we go to explorer.solana.com. We go set ourselves up on local. And we go to our program. We can see our smart contract has a program account. The address is here. We can see what the balance of SOL to store it was, and then when it was deployed. And we can see a bunch of information of like, this is the upgrade authority of myself who deployed it, and a bunch of other information of whether or not it's upgradable, it's executable because it is a smart contract, etc. And now that it is deployed, we also we'll need to start setting up the actions to interact with that smart contract on our local test validator. So we created this, we installed this actions SDK, and the next step will be that we have to set up this GET request and this POST request to actually do something on chain. If we don't have those, it won't actually do anything on chain within these blinks. So there's a life cycle diagram here. Basically, what we'll have is that someone will do something or click a button. It'll send a GET request to get metadata on what are the available actions that this user can do to your server. This will show up on the UI. The UI will then allow them to click a button to perform an action, which will make a POST request with their specific account public key to the action provider or our action server. We'll then respond with a serialized transaction. We'll show the transaction details to the user, allowing them to sign that transaction. And then they can approve it if they want, and it will actually interact with the Solana blockchain. So that's the full end-to-end of how Blinks and Actions works. So first off, let's create this GET request to get the right information to do our actions. So let's go pull down here. We can see there's a bunch of information about Blinks. We'll get to this in a moment. But ultimately, our GET request has to have a Solana action URL that describes an interactive request for the signable Solana transaction or message. So let's go ahead and do that. So what we can do is we can go into our web app API and create a new folder we'll call it vote. I'm just going to copy and paste this route so that we have a single GET request. That's fine. And if we ran this successfully, which if you're not already running your server, you would just do npm run dev, and that will run both your front end and your server side. We can go ahead and check if this GET request actually exists by going to our local host and going to, API vote. So let's go ahead and check it out. So if you go to localhost 3000, should be API/vote, and this should return some information, hello from the API. This is the very basic Next.js server-side work. Just as a note, we are creating quite a heavy application for these Blinks. Next.js server-side is quite heavy for this usage. Recommend like a Node.js server if you can, like an Express server. But because we have our scaffold and we'll later on in this course build the actual front end for the voting application, we're just going to use this back end and bootstrap it with this voting action. All right, so we got some information from our server using the API vote. Next up, we need to actually return valuable information in order to display the blink on any social media. So let's go ahead and do that. All right, so if you go to the Solana documentation, again, for actions, you can see that the metadata expected is this action GET response. It has an icon, a title description, your label, has some links and linked actions, and then an error. So there's a bunch of different information that you can respond via this GET request. So if we go over here, we can go ahead and create that. So we can do a const, we can call this the action metadata equals of type, this is actually type action GET response. Equals, and now we're going to start filling in our metadata. Action metadata is required. Missing properties, yep. So it's just saying, hey, you're missing some properties, icon, title, description, and label. So we're going to fill those in real quick. I'm going to fill them in with nothing just so that everything will play nice, and then we'll actually fill in with the real information. So action, it's icon, title, description, and there's one other thing, and it's label. All right, so we have some basic action get response metadata. Now we actually need to fill it in. So first off, what we're doing for this is we're creating a voting application that can be viewed, and we need to create an icon that is choosing between crunchy and smooth peanut butter.